right. What's up? What's up today? Welcome one more time. I am so excited, man, to just come in today and do this. So, let's go, right? For whatever reason, like I hope my screen is being recorded. I forgot how it works. Yeah, but I think it works. So, let's go, man. All right, so today, let me get the water first. Yeah. We are doing chapter 5, higher order functions, and I'm excited to just get into the meat and potatoes of this book. Alright, so higher order functions. Zuli and Tutu were boasting about the size of their latest programs. 200,000 lines, said Zuli, not counting comments. Tutu responded, Psst, mine is almost a million lines already. Mr. Yuan Ma said, my best program has 500 lines. Hearing this, Tuli and Tutu were enlightened. Master Yuanma, the book of programming. There are two ways of constructing software design. One is to make it simple. The other obviously that there are obviously no deficiencies, and the other way is to make it so complicated that there is no obvious deficiencies. All right. So these are like hieroglyphs. So a large program is a costly program, and not just because of the time it takes to build. Size almost always involves complexity, and complexity confuses programmers. Confused programmers in turn introduce mistakes, bugs into programs. A large program then provides a lot of space for these bugs to hide, making them hard to find. Let's briefly go back to the final two examples programs in introduction and first self-contained cell. The first is self-contained and 6 lines long. Let total be 0 and count 1. While count is less than 10, total is equals or plus count plus or equals to 1. Console.log total. Alright, and let's just copy this. I just discovered that I can do this on this software called GSBin. Alright, so I've just run 55 on my console. The second relies on two external functions and is one line long. Console.log sum of range 1 to 10. Let's run that. Run. We'll get 55, but we also get a reference error that sum is not defined. Interesting. Which one is most likely to contain a bug? If we count the size of the definitions of sum and range, the second program is also big, even bigger than the first, but still, I'd argue that it's more likely to be correct. It's more likely to be correct because the solution is expressed in a vocabulary that corresponds to the problem being solved. Alright, so here we've just talked about vocabulary of the problem being solved. Summing a range of numbers isn't about loops and counters, it's about ranges and sums. Alright? The definitions of this vocabulary, the functions sum and range, will still involve loops, counters, and other incidental details, but because they are expressing a simpler concept than the program as a whole, they are easier to get right. Abstraction. In the context of programming, these kind of vocabularies are usually called abstractions. Abstractions hide details and give us the ability to talk about problems at a higher or more abstract level. As an analogy, compare these two recipes for pea soup. The first one goes like this. Put 1 cup of dried peas per person into a container. Add water until the peas are well covered. Leave the peas in water for at least 12 hours. Take the peas out of water and put them in a cooking pan. Add 4 cups of water per person. Cover the pan and keep the peas simmering for 2 hours. Take half an onion per person. Cut it into pieces with a knife. Add to the peas. Take a stalk of celery per person. Cut it into pieces with a knife. Add to the peas. Take a carrot per person. Cut it into pieces with a knife and add it to peas. Cook for 10 more minutes. And this is the second recipe. Per person, 1 cup dried split peas, half chopped onion, a stalk of celery and a carrot. Soak peas for 12 minutes, simmer for 2 hours in 4 cups of water per person, chop, add vegetables, cook for 10 minutes. The second is shorter and easier to interpret, but you do need to understand a few more cooking related words such as soak, simmer, chop, and vegetable. When programming, we can't rely on all the words we need to be waiting for us in the dictionary. Thus, we might fall into a pattern of the first recipe. Work out the precise steps the computer has to perform one by one, blind to the higher level concepts that they express. It is a useful skill in programming to notice when you're working at a too low a level of abstraction. Abstracting repetition. Plain functions, as we've seen them so far, are a good way to build abstraction, but sometimes they fall short. It is common for a program to do something a given number of times. You can write a loop for that like this. For let I be 0 if I is less than 10, I plus 1 or plus every single time. Console.log I. This is the for loop. Can we abstract doing something n times as a function? Well, it's easy to write a function that calls console.log n times. Function repeat log n. For let I be 0, I less than n, then I plus, then console.log I. But what if you want to do something other than logging the numbers? Since doing something can be represented as a function, and functions are just values we can pass our action as a function value. So we create a function called repeat, and we pass n and action. And in this function, we want to pass these parameters for a loop. Let I be 0 and I is less than n, counter or add I. Then want to run another parameter, run or call action. Then step out of that, step out of this. Repeat 3 console.log. We'll get 0, 1, 2 continuously. So let's just copy this code. Let's clear this. Let's clear this and then let's run it. 0, 1, 2. Cool. We don't have to pass a predefined function or to repeat. Often, it is easier to create a function value on the spot instead. Let labels be an empty array. Repeats 5, I, arrow function, and then labels.push, we're going to pass this parameter, and then unit, what was this one called? temporal what? Temporal value, I guess. I plus 1, close console.log labels. It will print unit 1, unit 2, unit 3, unit 4, unit 5. What have they just done here? I think what they've done is removed a lot of the verboseness and used, for example, like now, instead of function, they've used the arrow function key here. What do you call that type of string? Yeah, template literals. Yeah. So template strings. This is a template literals. Template literals. This dollar here. This is a template literal. Unit template literal. I plus 1. This is structured a little like a for loop. It describes the kind of loop and then provides a body. However, the body is now written as a function value, which is wrapped in the parentheses as to call repeat. This is why it has to be closed by closing brace and a closing parenthesis. In cases like this example where the body in a single small expression, you should also omit the braces and write the loop in a single line. So I think repeat 5 times. I think this will repeat. Okay, fine. Just the same as, for example, here. Repeat 3 console log. All right. Okay. Higher order functions. All right. Functions that operate on other functions, either by taking them as arguments or by returning them, are called higher order functions. Functions that operate on other functions, either by taking them as arguments or returning them, are called higher order functions. Since we have already seen that functions are regular values, there is nothing particularly remarkable about the fact that such functions exist. The term comes from mathematics, where the distinction between functions and other values is taken more seriously. Higher order functions allow us to abstract over actions, not just values. They come in several forms. For example, we can have functions that create new functions. For example, we had function be greater than n, and we wanted to have the parameters return m. Then another function, arrow function here, m over greater than m. Close that. Let greater than 10 be greater than 10. Console dog greater than 10. 11, which is true. And we can have functions that change other functions. For example, function noisy_f returns what did I learn? These 3 dots, 3 dots in JavaScript. Haha, I just have to know right now before allows to expanded. Okay, spread syntax. Okay. This is more like they're expanding this language in front of our eyes. So return and then args arrow function, going to pass in the parameters console.log string calling with args, close that. Let result be f args console.log called with args returned result, step out of it. Noisy math.min 321, and then it will say calling with 3 to 1, then called with 3 to 1, returned 1. So this is a function that changes other functions. We can even write functions that provide a new type of control flow. We're getting really tough now. Function unless test, then going to pass in the parameter if not test, then this is a function. I think you can run this function. Step out of it, repeat 3, function n, unless n remainder 2 is equals to 1, call the function, then arrow function, run console.log n is even. Wow, what did they just do? I'm gonna give up. So this is a built-in array method for each that provides something like a for loop as a higher order function. Arrow array string A, string B for each, and then going to from the parameter L, arrow function console.log L. It will give you a B. And this is something I need to come back maybe because I think I just read it. Script dataset. One area where higher order functions shine is data processing. To process data, we need some actual data. This chapter will use dataset both about scripts, writing systems such as Latin, Cyrillic, or Arabic. Remember Unicode from chapter 1? The system that assigns a number to each character is in written language. Most of these characters are associated with a specific script. The standard contains 140 different scripts. 81 are still in use today and 59 are historic. Though I can fluently read only Latin characters, I appreciate the fact that people are writing texts at least 80 other writing systems, which many I wouldn't even recognize. For example, here is a sample of Tamil handwriting. Tamil, which country is Tamil from? India? India. So, okay. This is Tamil. The example dataset contains some pieces of information about the 140 scripts defined in Unicode. It is available in the coding sandbox for this chapter as the scripts binding. The binding contains an array of objects, each of which describes a script. For example, name, Coptic, ranges, array 1994, 1008, 11392, 11,508, another array 11,515, 11,520, close that array, direction left to right, year less than 200, leaving false link, Wikipedia. Such an object, this is an object we just, so these are a bunch of objects, or this is the object. Such an object tells us the name of the script, the Unicode ranges assigned to it, the directions in which it is written, the approximate origin time, whether it is still in use, and a link to more information. The direction may be left to right for left to right, or right to left for right to left, the way Arabic and Hebrew texts are written, or TTB from top to bottom, as with Mongolian writing. The ranges property contain an array of Unicode characters ranges, each of which is a two-element array containing a lower bound and an upper bound. Any character codes within these ranges are assigned to the script. The lower bound is inclusive. Code 994 is a Coptic character, and the upper bound is non-inclusive. Code 1008 isn't. Filtering arrays. So to find the script in the dataset that are still in use, the following function might be helpful. It filters out the elements in an array that don't pass as a test. Function, or creating a new function, call it filter, then going to have array and test, then the parameters will be let past be an array. For let element of array, if test element, and then you're going to run inside that past push element, then return past. Console.log filter scripts, and then script arrow function, script.leaving. It will give you an array name, addlam, so on and so forth. The function uses the argument named test, a function value, to fill a gap in the computation. The process of deciding which elements to collect. Note how filter function, rather than deleting elements from the existing array, build up a new array with only the element that pass the test. This function is pure. It does not modify the array given. Like for each, filter is a standard array method. The example defined the function only show what it does internally. From now on, we'll use it like this instead. Console.log script filters s arrow function s direction top to bottom, and then name Mongolian etc etc. Transforming with map. Say we have array objects represent scripts produced by filtering the scripts array somehow, but we want an array of names which is easier to inspect. The map method transforms an array by applying a function to its elements and building a new array from the returned values. The new array will have the same length as the input array, but its contents will have been mapped to a new form by the function. Function map dot transform let mapped for element of array map dot push map, then transform element return maps, then let right to left scripts be scripts filter, then we're going inside that scripts filter going to run s arrow function s direction is equal to right to left, then console.log math map right to left scripts s arrow function s name. It will give me Adlam, Arabic, Imperial, Aramaic. Like for each and filter, map is a standard array method. I think here we've been introduced to a bunch of new array methods. So summarizing with reduce. Another common thing to do with arrays is to compute a single value from them. A recurring example, summing a collection of numbers, is an instance of this. Another example is finding the script with the most characters. The higher order operation that represents this pattern is called reduce, sometimes also called fold. It builds a value by repeatedly taking a single element from the array and combining it with the current value. When summing arrays, you'd start with the number 0 and for each element add that and to their sum. The parameters to reduce are, apart from the array, a combination of functions and a start value. The functions is a little less straightforward than filter and map, so take a look at it. Okay, so function reduce, going to have array combine and start. Inside that we're going to pass the following parameters. Let current be start. For let element of array current be combine, going to run current element, then return current. Console.log reduce this following array 1 2 3 4, then a and b arrow function a plus b 0. It will give you 10. The standard array method reduce, which of course corresponds to this function, has an added convenience. If your array contains at least one element, you are allowed to leave the rest leave off the start argument. The method will take the first element of the array as its start value and start reducing the second element. Console.log 1, 2, 3, 4 dot reduce, going to pass inside there AB arrow function A plus B. It will give you 10. So to use reduce twice, to find the script with the most characters, we can write something like this. Function character count script, want to return script ranges, and then reduce count from to arrow function, run the following parameters, return count plus 2 to from, close that, 0, close step out of that, then close the function. Console.log scripts reduce A, B function, return character A less than character count B, or B A full stop, name Han. I'm so floating, but I know they're now combining different concepts that we learned, but I was having such a hard time. Water. Will I know how to abstract? The character count function reduces the ranges assigned to a script by summing the sizes. Note the use of destructuring in the parameter list of the reducer function. The second call to reduce this uses this to find the largest script by repeatedly comparing two scripts and returning the larger one. The Han script has more than 89,000 characters assigned to it in the Unicode standard, making it by far the biggest writing system in the dataset. Han is a script sometimes used for Chinese, Japanese, and Korean text. Those languages share a lot of characters, though they tend to write them differently. The US-based Unicode consortium decided to treat them as a single writing system to save character codes. This is called Han unification and still makes some people very angry. Composability. Consider how we would have written the previous example, finding the biggest script without higher order function. The code is not much worse. It's not that much worse. Let biggest be null. For let script or scripts. If biggest is null, or character count biggest is less than character count script, biggest equals script. Then console.log biggest. There are few more bindings and the program is 4 lines longer, but it is still very readable. High order functions try to shine when you need to compose operations. As an example, let's write a code that finds the average year of origin for living and dead scripts in the dataset. So function, average array, return, inside that we're going to pass this parameter return, array.reduce, AB, arrow function A plus B, array.length. That's our new line. Console.log math round, average, we're going to pass in script filters, s arrow function s.living, map s arrow function s.here, 156. Console.log math round average, script filter s arrow function not s living, map s arrow function s here, it will get 204. So the dead scripts in the Unicode are on average older than the living ones. This is not terribly meaningful or surprising statistic, But I hope you'll agree that the code used to compute it isn't hard to read. You can see it as a pipeline. We start with old scripts, filter out and allow the dead, living or dead ones. Take years from those, average them, and run the result. You could definitely also write this computation as one big loop. Let total be 0, count be 0, for let scripts of scripts. If scripts.living is going to write this total plus script.here count plus 1. Also.log math.round total of account 1165. But it's harder to see what was being computed and how. And because intermediate results aren't represented as coherent values, it a lot more work to extract something like average into a separate function. In order of what the computer is actually doing, these two approaches are also quite different. The first will build up new arrays when running filter and map, whereas the second only some numbers doing less work. You can usually afford the readable approach. But if you're processing huge arrays and doing so many times, the less abstract style might be worth the extra speed. Strings and characters. One of the data set would be to define figuring out what script a piece of text is using. So let's go through a program that does this. Remember that each script has an array of character code ranges and associated with it. So given a character code, we could use a function like this to find the corresponding script if any function character script code for let script or scripts if script ranges dot sum from array from to then arrow function return code less or greater than or equals to from and code less than 2 return script then return null. Console.log character script 121 name Latin. So the sum methods is another higher order function. Where is it? Here, sum. It takes a test function and tells you whether that function returns any of the elements in the array. But how do we get the character codes in a string? In chapter 1, I mentioned that JavaScript strings are encoded as a sequence of 16-bit numbers. They are called code units. A Unicode character was initially supposed to fit within such a unit, which gives a little over 65,000 characters. When it became clear it wasn't going to be enough, many people balked at the need to use more memory per character. To address this concern, UTF-16, the format used by JavaScript strings, was invented. It described most common characters using the 16-bit code unit, but uses a pair of such two unit for others. UTF-16 is generally considered a bad idea today. It seems almost intentionally designed to invite mistakes. It isn't easy to write. It's easy to write programs that pretend code units and characters are the same thing. And if your language doesn't use the two characters, that will appear to work just fine. But as soon as someone tries to use such a program with some less common Chinese characters, it breaks. Fortunately, the advent of the emoji, everybody has started using 2-unit characters, and the burden of dealing with such problems is more fairly distributed. Unfortunately, obvious operations on JavaScript strings, such as getting their length to the length property and accessing the content using square brackets, deal only with code units. For example, 2 emoji characters horse and shoe, let horseshoe be horse and shoe. Console.log horseshoe length, it will give you 4. Console.log horseshoe 0, invalid half character. Console.log horseshoe.char code at 0, 55377 code at the half character. then console.log horseshoe code point 0, and then it will give you that. JavaScript's char code at method gives you a code unit, not a full character code. The code point at method added later does give a full Unicode character. So we could use that to get characters from a string, but the argument passed to code point at is still an index into the sequence of code units. So to run over all characters in a string, we'd need to deal with the question of whether a character takes up 1 or 2 code units. Whew. In the previous chapter, I mentioned that a for or off loop can also be used on strings, like code point at. This type of loop was introduced at a time where people were acutely aware of the problems with the UTF-16. When you use it to loop over a string, it gives you real characters, not code units. So let rose dragon be emoji rose dragon. For let character of rose dragon console.log character, it will give you rose dragon, rose and a dragon. If you have a character which will be a string, if you have a character which will be a string of 1 or 2 code units, you can use code point 0 to get its code. Recognizing text. We have seen character script function as a way to correctly loop over characters. The next step is to count the characters that belong to each script. The following counting abstractions will be useful there. Function count by, going to have items and group name. Inside that, let counts be an array. For let items of items, let name group name item, let none be equals to counts dot find index, which is a new function. C arrow function c dot name is equal to name if none is less than 1. Counts push name count 1, else counts array none dot count then plus plus. Return counts. Console.log count by array 1, 2, 3, 4, 5, comma n arrow function n over 2. Step out of it. It will give you arrow function object name false count 2, object name true count 3. The count by function expects a collection, anything that we can loop over with a for of, and a function that computes a group name for a given element. It returns an array of objects, each of which names a group and tells you the number of elements that were found in that group. It uses another array method, findIndex. This method is somewhat like index of, but instead of looking for a specific value, it finds the first value for where the given function returns, like index of, and returns -1 when no such element is found. Using count by, we can write the function that tells us which scripts are used in the piece of text. So function text scripts text. Oof, this is kicking my butt. I have no idea. I'm gonna have to. I know I'm gonna have to reread this chapter. Function text scripts text. Then let scripts be count by. Text character arrow function. Let scripts be character script dot char dot code point at 0. Return script name none. Then filter name, then name is not equal to none. Let total of the scripts dot reduce be n count arrow function n plus count 0. If total is equals to 0, return no scripts found. Return scripts map name. The what? Let me just finish reading this and then I'm going to. So it's pretty obvious that I'm going to have to repeat this. Summary. Being able to pass function values to other functions are deeply useful aspect of JavaScript. It allows us to write functions that model computations with gaps in them. The code that calls these functions can fill the gaps by providing function values. Array provides a number of useful high-order functions. You can use for each to loop over each of the elements in the array. The filter method returns a new array containing only the elements that pass the predicate function. Transform an array by putting each element through a function is done with the map. You can use reduce to combine all the elements into an array into a single value. The same method tests whether an array matches a given predicate function, and find index fills the position of the first element that matches a predicate. So I think we have learned that JavaScript has a method. Yes, let me just look at the. Let's start with. I should have found it on W3 schools. Right, function properties. And I can already see that there are so many indexed collections, int16 array, float32 array, map, set, weak map, weak set, array buffer, weak ref. And I think what I'm learning, switch, throw, try and catch, break, block, var, let, const. I think what this chapter that has been such a kick in my butt has done for me is to let me know that JavaScript has all these functions and methods that allows you to add abstraction to something that you would have done. It would have taken you a very long time maybe to do with a for loop or the basic things that you've done. We can use some of these higher order functions that I've just seen here. And I'm gonna come back and just reread this, but that was good to know. It's really a pain to go through this one, but I know definitely I'm gonna have to go through it again. Alright, so that was chapter 5, hardest one yet. Whew, that was a doozy, bro.